Welcome to Shiny Calibration. This is a new Shiny that you can use to calibrate any compounds that you've included in a standard mixed within a series of concentrations. As input, you need to have your set of measurements, and then these set of measurements have to be sent through the converter in a normal way. However, you've got to mark up your calibration samples as sample type calib, and you have to enter a column called cons, giving the concentration for each of these calibration samples. So you can either do this before the converter in the sample list, or you can do it afterwards. But this is what is needed as an input. So these ones will be used to generate the calibration curves, and these samples down here will be calibrated. It is assumed that these concentrations here, 250 are nanogram per milliliter, and that they're the same for each and every one of the compounds that are to be calibrated. And that's what we have in these mixes. So this is what you start with. The rest of the file is just a simple. It's just what it always is. So this is a calibration that this is the BZ negative data set. And now we're going to go into calibration. And so the first tab is in file, where you simply have to upload your file. This is the file that I showed you, the converter output file. And I think this is in here. Yes, open. And then you have to wait for a few seconds while the program calculates everything. So what's on this first, the plot here is, we just leave that on one side for the moment, but then you go to the plotter. And on the plotter, you can choose some compounds to plot. And this will give you these calibration curves, which are the ones that I showed in the meeting that we had some weeks ago. So you can play around with the cutoff. This will have the effect that some points will be red now because they've got too large a cutoff. You can choose R2 cutoff, which will mean that certain compounds will be excluded altogether. And this one here will also mean that some compounds will be excluded if they have fewer than 5 points. So these calibration curves should have 10 points. So so you could set this also to 8, and then some compounds would have to go. Now so this is more or less the same as what I've showed you before. Now the difference to previously is that well, first of all, in the in file you load the calibration samples and the data that is to be calibrated in together in this Excel sheet. So it's both the calibration samples and the actual samples. They're together in one file, as you will very often have. And that now in the out file you have a few options. So first of all, you can add a dilution factor. So that means that if you put in here a dilution factor of 10, then all your concentrations will be multiplied by 10. So it means a dilution factor means the sample was diluted 10 times before it was measured. So to get back to the original concentration, we need to multiply by this dilution factor. To reiterate the assumption is that the injection volume for the calibration samples and the actual samples is the same amount, so that this cancels, so we don't need to correct for that, and that the units of the concentrations in the input file are in nanogram per milliliter. However, if we want to export, we can have them either in nanogram per milliliter or in nanomolar. This is converted via the molecular formulas that are now must be present here in this column. They are, so this comes out of almost all of the export formats that we use. We almost always have a formula that can be used directly. And that's what I use to convert the units. So this now means that there will be, you can have these two units when you save. So let's save. Let's put it in here. So let's put this here, calibration out. And let's open it in Excel. And now, what have we got here? So, you will find that this is now an input for Super Shiny. So, in terms of samples, all the calibration samples are gone. They're not there anymore because for Super Shiny they won't be used. They can't be used. In the features, we have gained a few columns, and this is interesting stuff. For one thing, it's the R2. Then it's count, that's how many points of your calibration curve were accepted, not rejected. The curve, that is the curvature, that is a sort of similar measure to R2, the one that I prefer to use. This one's more sensitive. And here we have two values, cons low and cons high. These are the two concentrations that are within the accepted range. Yeah, so here we had 9 points. This is the lower end of of these 9 points. This one's the lower one, and this one's the higher one. And here, where we only have 8, we only go up to 125. So this tells us whether we've got a problem here. So in terms of measurements, there's, let's see. So we now have a bit of a sort of more confusing picture because we have gained a few columns. So so here's the peak area original. And then here is then the concentration raw. So this is sort of going through the calibration process. Then it tells you whether this point is in the good range. Then is the concentration, which is if you use the dilution factor, then this would be calculated here. We had a dilution factor of 1. I didn't change the dilution factor. So this would come in here. And then you can convert to concentration nanomolar. Now, so all of these calculation steps are in this sheet, and you can sort of check them manually if you like. What is somewhat counterintuitive is that there is still a column called peak area, because this is actually the column that Super Shiny reads. So this will be identical to concentration or constant nanomolar, depending. And So when you go into Super Shiny, this will still read this column peak area. This is this is sort of the workaround for now that I'm using. Yeah, that Super Shiny always reads sample ID, feature ID, peak area. But anyway, you can then go through Super Shiny, and what will come out will be in the units of either nanogram per milliliter or nanomolar.